initialization. So in every machine learning model, or like initialization is very critical step. Okay, so if you can recall from our previous sessions, when we have discussed about linear regression, logistic regression, and many others, what we have done is we have initialized our weights with zeros, right? So initialization with zero weights. So there is a problem regarding this. So in case if you can initialize with zero weights, what happens is, so let's take the same values over there. If we can observe, well, let's say like we are calculating W1. If you can observe the values over here, so it means, let's see. So, okay, so when you are initializing weights with zero, let's assume take the same weights here, like weight matrix W1 equal to 0, W2 equal to 0, and W3 equal to 0. So let's take this scenario. And now, like we know that like for training a model, what we do is like we have a data here, and with the labels like data with features, I mean like features and expected value, right? Expected output. Let's say these are the two things which we have for the data, and this data, what we do is like we'll send the input to a neural network. So and this neural network, what it will do is like it will calculate the output, like prediction, let's say predicted output. So what we do is now we'll be calculating a loss function depending on our predicted and expected output, right? Will calculate loss. Depending on that loss, we'll then this loss actually will be doing optimization based on like let's say gradient descent, and this gradient descent will do updation of weights over here. So using the formula like weight new weight equal to old weight minus into d by dw, right? Using this formula, anyway, we have calculated a gradients over here. So using those gradients, it will update the weights of neural network. And with this, it will, after getting an optimal value, so what we do is we'll deploy that model where you send the data and it will predict the output. Okay. So this is how the training is done. So for training, as you remember here, we are using like W new equal to old minus alpha into d by dw, right? So let's take an example of like world W1, where W1 world minus alpha by dw1. So if you can see, in case if you initialize it with 0, what happens? This value will be 0, right? So once this value is 0, so okay, that is fine. So what about this value? So this, let's see here. So calculating dou by dou w, what we have is this term, this bigger term, right? So in that, if you can observe, there is this w here. Okay, this w, but actually if we initialize it with 0, what will happen to that product? Entire product will be 0, right? So it will be 0. So even your new w equal to 0. So similarly, when for w2 as well, so if you see w2, it has a term w3 here. So but while in case you initialize it with 0, so this product will also be 0. So your gradient is 0. So as your gradient is 0, what will happen over here? Your new values of new equal to 0. Similarly, the third one, right? So all your values will stay at 0. Even previously, when we initialized it, it is like w1 equal to 0, w2 equal to 0, and w3 equal to 0, right? So even we perform a gradient descent step, still we have this w1, w2, and w3 as 0. So and let it go for like many iterations, but it doesn't change, right? So it is considered to be a dead network, right? So those neurons are dead because like you initialized with 0, and then because it's the gradient descent is not updating any values and it's still remains the same at 0. So the output of the network of that cells will be 0, right? So in that case, what will happen? This doesn't learn anything. It will always give you the same output what it is there earlier, right? So this is not recommended at all. Like, and you should be very cautious. Never initialize a parameter here like your weights with 0. So this is like, you should be like very much cautious in like initializing for neural networks. So what else can be done, right? So this can be a question for us. So apart from zero initialization, we can also do a random initialization. So what random initialization will do is like it will actually like let's say, instead of previously we thought like it is 0 0 0, right? So instead of using these weight vectors, what we can have is, so this has created an issue. So instead of using these zeros, what we can do is this, we should not use, right? So let's write like this. So, and what we should use is, instead we should generate some random numbers within like let's say -1 to 1. You generate some numbers as like -1, 0.5, 0.2, -0.5, minus 0.2, something like this. It can be anything. Like I just wrote like these three, I'm repeating: 0.8, 0.1, 0.9, something like this. So we generate a random numbers. So within preferably 0 to 1 or -1 to 1, one of these. So, and then like use this as weight vectors, and similarly for the other weights layers as well. And then what we do is like we take these, like use it as an initial values over here, and from the gradient descent anyway it will optimize, like it will change the values to optimal values, right? So using gradient descent, these are initial values, then use gradient descent, train the algorithm, and finally like after few repeats, so what you finally get is optimal value. Okay, this will be getting. So but initialization should be random. There are many other initialization methods available which are being proposed like in different research papers. We will take a separate session on those, but as of now let's do only a random initialization.